Dust storms on Mars can really go crazy. They hurtle through the red planet's southern hemisphere, especially during the summer. These storms can grow and encompass large areas of the planet, as happened in January 2022. Then, a dust storm covered almost twice the area of the United States. Could it be something like this that caused one of the robots we sent to Mars to go missing? The atmosphere and climate are harsh on Mars. It's mostly a desert with strong winds and average temperatures of minus 81 degrees Fahrenheit. It drops down to minus 220 at the poles during the winter. A lander needs to be specifically equipped and very sturdy to withstand such conditions. But researchers thought the Beagle 2 could handle the difficult trip to the red planet. June 3, 2003. A team of researchers got one of their pioneering robots they were about to send to space ready. It was a small and compact lander called the Beagle 2. Its mission was to touch down on Mars and search for what the world has been actively looking for decades now: life on the red planet. Now, the touchdown was due on December 25th, but the signal never came. The team tried to contact the spaceship, but at one point, they had to accept they wouldn't be able to reach it. Some thought the landing was too difficult and complex after all, so the lander crashed. But they couldn't find any technical errors. Others had a theory that the lander may have become entangled in its own parachute and fell down to the surface of Mars. Either way, the Beagle 2 was considered missing, until 2015, when NASA took pictures of what could be the remains of the lost lander. They weren't just smashed debris, the components actually looked to be intact. The lander's remains were lying with its solar panels partially deployed around 3 miles away from the site where it was supposed to land. Apparently, the Beagle 2 managed to land successfully, but its radio antenna got blocked. That's why researchers couldn't control it from Earth or communicate with it. But no one knows exactly why it happened. Have you heard of a face on Mars? In the 1970s, one of NASA's spaceships took the iconic images of the Martian surface that showed a face-like formation, as you can see in the upper part of the picture. If you have a rich imagination, you can easily see a nose, 2 eyes, a mouth, and an unusual hairdo. Some even thought it was a monument built on the red planet by another civilization. How about some other unusual things people have found on Mars, like Happy Face Crater? You can easily see why it has this nickname. Or rocks in different shapes, a pancake, brachiosaurus, or a fish. Mars also has a waffle-shaped island on its surface. It's a 1.2-mile-wide feature you can see in the area of lava flows. It might be the result of lava pushing this formation from below. It seems astronomers have also got some images of blue dunes. It's a sea of stunning dark dunes that strong winds sculpted into long lines. They surround the planet's northern polar cap and cover a region as large as Texas. The red planet is usually known for its brown sandy dunes, so these ones certainly came as a surprise. In reality, though, they're not really blue. If you could visit Mars right now just to take a look, you'd see that these dunes appear brown and orange like the rest. And the picture is a false color image. Scientists often use false colors to highlight differences in something. For example, here it's the difference in depth. Also, the biggest valley on Mars is so large it could eat our Grand Canyon for breakfast. It's a fascinating system of canyons 2,500 miles long called Valles Marineris, and it's over 10 times as long as the Grand Canyon. Now, if you could stretch this Martian canyon, it would go from coast to coast of the entire United States. Since Mars doesn't have any active plate tectonics, no one knows for sure how this canyon formed. One theory says a chain of volcanoes located on the other side of Mars, the one that includes Olympus Mons, bent the crust from the opposite side of the planet. This powerful force caused cracks in the Martian crust as well as activated enormous amounts of water lying under the surface. This water then emerged and carved the rock away. The force activated glaciers too, and they possibly created new pathways in this gigantic canyon system. Volcanoes on the Martian surface could have erupted about 50,000 years ago, although the most powerful eruptions happened 2 to 3 billion years ago. But the planet doesn't have active volcanoes today. Most of the heat stored in its interior during the planet's formation has been lost. So now, Mars's outer crust is way too thick for the molten rock to reach the surface. But a long time ago, eruptions formed giant volcanoes, and these volcanoes most likely had an important role in melting ice deposits, which released floods of water onto the Martian surface. Now, Mars has a thin atmosphere with a volume of gas, mostly carbon dioxide, less than 1% of Earth's. But 4 billion years ago, it was way warmer and wetter than now. Its atmosphere must have been thicker back then, too. That's why it could create a powerful greenhouse effect and trap sunlight. Mars also has a powerful magnetic field. Similar to Earth's, it formed because of the currents of molten metals in the planet's core. But unlike our home planet, Mars lost its magnetic field after its core had cooled down. And without it, the planet didn't have any protection from the solar wind, which is a stream of charged particles flowing from the sun. The solar wind pulled away most of Mars's atmosphere in just a couple of 100 million years, give or take. This is what makes those powerful Martian dust storms even more intense. Mars has a fascinating history. Judging by the planet's glaciers, Mars has probably gone through multiple ice ages, just like Earth. A team of researchers got images of about 60,000 Martian rocks. Rocks were different in size and distributed randomly, which means they probably formed during different ice ages. Glaciers hide their own stories too. Who knows what kinds of gases, rocks, or even microbes could be trapped inside? Now, if you could get into a time machine and stop at 4 billion years ago, on Mars of course, the chances are you'd see spectacular scenes of flooding. Maybe there would even be some form of life on the planet's surface. A strong meteorite impact that formed the red planet's Gale crater could be something that triggered that mega flood. After that collision, the temperatures on the planet got insanely hot. This caused the melting of all that ice that was stored on the Martian surface at that time. The flooding was so massive, it changed the geological structure of the planet's surface. It carved out big ripples, as well as waves in the sedimentary rock. Now, speaking of water, vapor has been noticed escaping the atmosphere of Mars. Also, researchers have found some evidence of water flowing on the planet's surface. There are dark streaks in the soil. They seem to get bigger in the summer and shrink over the winter. There are numerous dried-out valleys and river channels on the planet. It's possible that liquid water once flowed there. Now, most of it could be locked up in ice caps or even hidden under the surface. More and more things hint that Mars used to be habitable. Mars is the only planet we know about where only robots live. 5 rovers make up the Martian population. Those are Perseverance, Opportunity, Spirit, Sojourner, and Curiosity. These robots are there to take pictures and samples of soil and air, and maybe even find life on the red planet. And someday, we may reunite with them on Mars. Who knows? Oh, and by the way, if you really could get into a time machine and stop at 4 billion years ago on Mars, then I'd like to buy you lunch and talk about it. My treat. Kaboom! One huge asteroid could be enough to wipe out all dinosaurs that ever roamed the Earth, leaving behind nothing but a huge crater. Yeah, we're in the Yucatan Peninsula, Mexico, and underneath there's Chicxulub, a massive crater. Now, if there's this immense hole, there must be a meteor too, right? Well, weirdly, no one has ever seen the actual remnants of the space rock itself. It's a bit weird, especially considering how important it is. After all, many think the same meteor that created the crater is the one that wiped out dinosaurs. Now, it might have vaporized on impact, creating a massive explosion. Most of the meteor could have turned into gas or tiny fragments scattered across the atmosphere. Or it might still be here, on Earth, just hiding. And scientists have finally discovered where to look for it. But it's not easy to reach. Around 66 million years ago, a giant asteroid went down and marked the end of the Cretaceous period. It slammed into what's now called Mexico, just north of Central America. The explosion from the impact triggered a global heat wave, which was followed by years of winter. It threw Earth into total chaos. The consequences of this catastrophe led to the extinction of more than 60% of life on Earth. including all the non-avian dinosaurs like T-Rex and Triceratops. It also took down flying reptiles, pterosaurs, and sea creatures like mosasaurs. Long story short, it was the end of the dinosaurs era. But don't be too sad about it, because it paved the way for the rise of mammals and you and me. Anyway, scientists have recently figured out where the infamous asteroid came from and where it ended up. The thing wasn't just wandering around Earth's neighborhood. This massive rock might have formed beyond Jupiter and headed straight for our planet. But we'll talk about that a bit later. First, let's look more closely at the collision that created the Chicxulub crater. When the asteroid slammed into Earth, rocks from deep within the planet's crust were thrown up to 15.5 miles into the sky. It also created mountains taller than the Himalayas around the crater's edge. The asteroid itself, called the Chicxulub impactor, was about 6 to 9 miles in diameter. It hit Earth at a speed of around 12 miles per second, coming in at a 60-degree angle. I know we're not in a geometry class, but the angle is important here, since it was exactly right to send the maximum amount of vaporized rock into the atmosphere. As a result, massive plumes of sulfur gases and fine dust shot up, blocking out the sun and causing what's known as an impact winter, which lasted about 15 years. At the time, dinosaurs reigned on Earth. They'd been around for nearly 200 million years before the catastrophe led to their disappearance. The meteor theory seems all plausible, and all the facts add up, but even now, not everyone agrees with that. Some believe that dinosaurs were already on the brink of extinction before the asteroid impact, and the collision might have just sped up the process. Anyway, most dinosaurs were wiped out, but if scientists are right, then those who somehow managed to survive were the ancestors of modern-day birds. So we have an idea of what might have happened, but it took years of studies. The crater was first identified by scientists working for Pemex, a Mexican oil company, in the 1970s. And sometime later, scientists finally realized the mass extinction event that ended the Cretaceous period was because of the Chicxulub. One piece of evidence that pointed to the asteroid were the local fish back then. You see, when the asteroid struck, the immense force of the impact reshaped the planet's surface. For example, it turned rocks into glass-like spherules. Now, spherules are like small spherical particles that can form from the rapid cooling of molten silica droplets. And some of these spherules ended up in the gills of fish that were wiped out by the impact. So, when during another research, scientists studied these fossils, it became obvious to them that the asteroid strike had happened during springtime in the northern hemisphere. They figured this out by studying the lines of growth in the fish's bones. Yep, those can be read just like tree rings. Of course, throughout many years, researchers continued exploring the impact site, hoping to find new data about the catastrophe. Their best bet was to turn to the chemical record left behind by the asteroid, the debris of which is hiding under all those layers of rock and sediment under the Yucatan Peninsula. So they studied the chemical signatures in rocks from the end of the Cretaceous period and found that the asteroid came from beyond Jupiter. And it wasn't just any asteroid. No, it was a carbonaceous chondrite, one of the oldest types of asteroids in the solar system. It most likely formed billions of years ago. These types of asteroids only come from the region beyond Jupiter. So the asteroid that caused the extinction event must have originated there. One of the main clues was ruthenium. It's a rare element in Earth's rocks, but much more common in asteroids. Scientists detected tiny amounts of ruthenium in the rocks, which helped them confirm that the asteroid came from outer space, not from a comet or volcanic eruptions. In 2016, scientists also published the first results from a drilling expedition into the Chicxulub crater. The team managed to drill more than 4,000 feet beneath the seafloor, getting their hands on core samples containing pieces of the original granite bedrock that was struck by the asteroid. These rocks are deeply shocked and placed out of order on top of sedimentary layers. It supports the theory that the peak ring of the Chicxulub crater formed through a dynamic collapse process. Now, about that peak ring. Scientists specifically targeted it in their exploration. The so-called ring is a circular ridge inside the crater rim. Similar peak rings can be found in the largest impact craters in our solar system, on the Moon, Mars, and Mercury. But on Earth, Chicxulub is the only well-preserved crater with a peak ring. This discovery also aligns with recent findings from NASA's lunar mission. It showed that the peak rings within the Orientale impact basin on the Moon had formed in an equivalent way to those at Chicxulub. The team is so eager to study the peak ring because they want to test their models of crater formation. Plus, they hope to find out whether this area could have been one of the first habitats for microbial life after the asteroid impact that wiped out dinosaurs. The peak ring formed just minutes after the impact. The deep granite bedrock, initially flowing like a liquid, rebounded into a central tower as tall as 6 miles before collapsing into the ridge we see today. This was followed by a layer of breccia. That's a jumble of rocks and impact melt. And after that, ocean tsunamis brought massive amounts of sandy sediment into the crater. Another find from 2016 was a 10-foot-long core, which revealed bits of granite and minerals from hot, fluid-filled cracks. That was a sign that they had finally entered the peak ring. Geophysicists from the University of Texas explained that they had expected the peak ring to be a large hydrothermal system, and they were drilling to confirm this. The team eventually reached deeper layers, drilling down to 4,380 feet. The team was able to collect most of the core samples they hoped to get, and the samples they got were in great shape. They also gathered lots of useful data from the early Paleocene period and completed a successful scan of the drill hole. Now, scientists from around the world will need some time to fully study and understand what these findings mean. But they're sure that this mission will help answer some big questions, like what exactly happened when the asteroid hit, how it wiped out the dinosaurs, and how impacts like that affect life deep underground. Well, it's official, there is life on Mars. No, it's not a clickbait. Let me break it down for you. Most people imagine extraterrestrial life as little green and, preferably, intelligent people. But we need to distinguish between life and intelligence. When someone tells you there's life on another planet, you probably immediately think about some smart being you can converse with. But life is something different. It's often associated with organic. And NASA's Curiosity rover has found the biggest organic molecules ever seen on the red planet. They were hiding in super old Martian rocks, and I mean about 3.7 billion years old. These kinds of molecules can be leftovers from stuff like fatty acids, which help build cell membranes. It may not be the life we're used to thinking of, but at the very least, the ingredients for what we call life have been there. So, NASA's Curiosity rover has been cruising around a huge crater on Mars called Gale Crater. Scientists think this crater used to be a lake several billion years ago. The rover's main job is to find out if Mars ever had the right conditions for life. And one day, Curiosity drilled into a chunk of ancient mudstone in a spot called Cumberland. It collected some rock powder, and scientists ran a special test on it using a tricked-out oven built into the rover. That oven gets really hot, about 1,500 degrees Fahrenheit. Luckily, the experiment's conditions allowed the researchers to cook off molecular oxygen, which limited the risk of combustion. And they found something surprising: chains of carbon atoms, up to 12 atoms long. You can find similar chains on Earth in everything from crude oil to, here we come again, living things. You may say that so far, the discovery doesn't sound too earth-shattering. But wait! Yep, these molecules can form naturally through non-living processes, like reactions with water, heat, and minerals. Hydrogen, carbon monoxide, heat, minerals – well, that's enough to cook up these molecules, even without biology. At the same time, such molecules are also common byproducts of life. Here on Earth, we produce similar compounds all the time, especially as carboxylic acids, which are everywhere in living organisms. So, even though these chains might have formed naturally, they could also be leftovers from something once alive, maybe microbial life, maybe something way more complex. We just don't know yet. But the most unusual and intriguing thing about the molecules is that these carbon chains are pretty fragile. On Earth, sunlight, air, and water would break them down over time. Yet, they're still on Mars after billions of years. So, even if these molecules don't belong to Martian dinosaurs, we now know that the red planet is good at preserving organic stuff. And this is huge for the search for ancient life. There's a good chance that chemical traces of that life might still be hiding in the rocks, and apparently, Curiosity is capable of detecting them. Now, by the way, this is not the first time Curiosity has found organics. It's also picked up chlorinated organics, sulfur-containing stuff, and nitrates, basically ingredients that, if life ever brewed on Mars, would have been part of the recipe. Now, how about we talk about another hero sent to Mars to make incredible discoveries? Meet Perseverance. It's a car-sized robot NASA once sent far away from home to the inhospitable and dry red planet. In particular, to an ancient crater called Jezero. The Jet Propulsion Lab created Perseverance and prepared it for its first space journey, which started on July 30, 2020. For 7 dark, lonely months, the robot was traveling through the cosmos. Luckily, it managed to land on Mars safely on February 18, 2021. NASA even gave its landing spot a cool name, Octavia E. Butler Landing, after the famous science fiction writer. Since then, Perseverance has been busy exploring the red planet. As of April 8, 2025, it's been active for 1,469 Martian days, which are, by the way, called sols. That's about 1,510 Earth days, or a little over 4 years. The rover looks a lot like its older sibling, Curiosity, but it boasts some upgrades. It's literally loaded with tech: 7 scientific instruments, 19 cameras, and even 2 microphones to record sounds from Mars, like the wind or the crunch of the rover's wheels over rocks. Perseverance also brought along a tiny flying buddy. It's a mini helicopter named Ingenuity. Ingenuity made history by performing the first powered flight on another planet on April 19, 2021. It was only meant to fly a few times, but it kept going and made 72 flights in total. Unfortunately, on January 18, 2024, it got damaged during a rough landing, so NASA officially retired it. As for Perseverance, it has big goals. It's searching for signs that Mars once had life, especially in areas that used to have water. In its search, the rover is trying to figure out if the red planet even had the environments that could have supported life. It's also searching for past microbial life, collecting rock and soil samples to bring back to Earth one day, and testing out cool tech, like making oxygen from the Martian air to help prepare for future human missions. After landing in Jezero Crater in 2021, Perseverance got to work right away, starting with its first campaign called Crater Floor. It drove south from its landing site and explored a spot called Saita. Then it returned to Crater Floor, Fractured Rough, and collected its first rock sample there. This was just the beginning of its exploration of Mars history. In its second campaign, Fan Front, the rover made its way toward an ancient delta where a river used to flow into the crater. Perseverance climbed up a valley to check out higher ground, looking for more clues about the past of the red planet. The third and fourth campaigns, Upper Fan and Margin Unit, had the rover studying rocks that could tell us more about the planet's climate and whether it could have supported life. In December 2024, they started planning Perseverance's fifth campaign, Northern Rim. It's supposed to study the crater's rim, where rocks from deep below the surface were blasted to the top during an impact billions of years ago. Perseverance has made some awesome discoveries so far. It found volcanic rocks on the crater floor that showed they interacted with water. This was a surprise, because scientists thought the rocks would mostly be sedimentary, not volcanic. At a place called Wildcat Ridge, the rover even found signs of an ancient lake that could have supported life. The rocks Perseverance has found are great at preserving potential signs of past life, so this is a really big find. The rover has also discovered some of the sediments in the delta were deposited by calm waters. But later, massive floods brought large boulders into the crater. It means that Mars's climate must have been changing over time. Now, on top of that, Perseverance has done a few cool experiments. The MOXIE experiment managed to produce about 4 ounces of oxygen from the Martian atmosphere. It could be really helpful for future human missions. The rover also used its microphones to study sounds on Mars. It turned out that sound traveled more slowly there than on Earth. Plus, it was quieter on the red planet. The rover's Pixel tool analyzed rocks and found a bunch of minerals like ovoline, clays, and carbonates. This discovery showed that water had always played a big part in shaping Mars. The RIMFAX radar also helped the team see that the crater floor was made up of solid rock and volcanic material, and that the delta had formed in a calm lake-like environment. All in all, Perseverance has been giving us a much clearer picture of Mars's past. It's discovering evidence of volcanic activity, water, and environments that could have been suitable for life. It's also helping scientists gather crucial data for future missions. By studying the planet's geology, atmosphere, and potential for life, Perseverance is setting the stage for future exploration, and one day, maybe even for humans to walk on Mars. So, in the end, will the Sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the Sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation Event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation Event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in 1 billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mobile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances, and somehow life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in a billion years. The red parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Mars quakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Marsquakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight's seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight's seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about two-thirds of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock or several smaller impacts, once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Marsquake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, caused Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet but later stopped. At some point in the past, Mars had moving tectonic plates like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Marsquakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission officially ended on December 21st, 2022. Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sunthun Kangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions. So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle. It's way thicker. And this is the core. Wait, what's happening here? Uh-oh. The core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's central Anatolian plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen for around a half-mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian Plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow! A space mission like this has never been done before. Nearly 20 years in the making. It's so precise that even a millimeter of error could ruin the whole thing. Two satellites are floating hundreds of miles above the Earth with one big goal: to create artificial solar eclipses on demand. This could change how we study the sun forever. But pulling it off is insanely difficult. And let's just say, NASA and the ESA are holding their breath. Proba 3 has successfully launched and already shows promising results. It's made up of two satellites that will fly in perfect formation. Their goal is to block out the sun in space. Well, why do we need that? Because solar eclipses are actually very useful for studying the sun's corona, its glowing outer atmosphere. The sun is obviously super bright, so its corona is only clearly visible during rare fleeting moments when the moon perfectly covers the star during an eclipse. But what if we could recreate that effect anytime? That's Proba 3's main task. One satellite acts as an occulter, a giant sun-blocking disk. It also carries a wide disk about 5 feet wide, which acts like an artificial moon, blocking out the sun's light. The other is a coronagraph. It should capture detailed images of the corona. There's also a third device that should study space weather and how solar storms affect our planet. It's insane how perfectly precise they must be for this to work. They must stay perfectly aligned with their position shifting by no more than a single millimeter, about the thickness of a fingernail, all while they're floating high away from Earth in space with no strings attached. This project was a team effort and a pretty big historical moment. This is the first time that an ESA mission is launched from India since 2001. Proba 3 was built with contributions from 13 European countries, along with Canada. There was a small hiccup before departure, though. The air freight company refused to accept the satellites because their batteries were still inside. The engineers had to remove the batteries and ship them separately. Not ideal, but a small price to pay for getting the mission to the launch pad. The idea first came to mind in 2005 to ESA scientists, and after years of planning, designing, and testing, the mission finally lifted off on December 5, 2024. For the first few weeks after launch, the two satellites stayed connected. Scientists run tests to ensure they were functioning properly. During this time, the coronagraph took its first-ever space image. It captured a beautiful star field in the Ophiuchus constellation. Then, on January 14, 2025, the real mission began. The two spacecraft successfully separated from each other. Over the following weeks, ESA's engineers carefully brought them back together to keep controlled distance. Now that they're in orbit, Proba 3 satellites work in a highly elliptical orbit, swinging between 372 and about 37,000 miles from Earth. This should help ease the Earth's gravitation, meaning the satellites won't need to burn as much fuel to stay perfectly aligned. The spacecraft also communicate with each other using lasers, adjusting their distances in real time. This level of control has never been attempted on this scale before. But the Proba 3 mission isn't only about looking at the Sun. The second satellite, the occulter, has its own mission. It carries DARA, an instrument that will measure the Sun's total energy output. This is incredibly important for climate studies. Scientists need to know how much solar energy reaches Earth. If Proba 3 succeeds, it'll prove that satellites can fly in space autonomously while staying super precise. This could open the door to entirely new types of space missions. For example, giant telescopes in space, where separate satellites act as one enormous lens. Or more advanced climate monitoring with precision instruments orbiting Earth together. Finally, deep space exploration. Spacecraft could team up to explore planets and moons in ways never seen before. 2025 is going to be full of insane space missions. It's packed with lunar landings, asteroid visits, and planetary flybys. But space is never easy. Missions get delayed, some never launch, and others surprise us. First, IMAP, Interstellar Mapping and Acceleration Probe. This one will launch in September, and it should help us unlock the secrets of interstellar space. It will travel super far away to study the boundary between our solar system and interstellar space. This mission will help us learn more about cosmic rays, solar winds, and what happens when the Sun's influence stops and the actual terrifying space begins. Next, PUNCH and SPHEREX. These two were already launched on March 11, 2025. PUNCH will help predict solar storms before they hit Earth. It will track solar winds from the Sun to Earth and help us understand space weather better. Space weather is important because it can damage satellites and power grids. And SPHEREX will map the entire sky in infrared light, capturing the spectra of millions of galaxies. It could reveal the secrets of how galaxies formed after the Big Bang. Next, we've got TON-2, which should launch sometime in May. It will visit the legendary asteroid Kamao'aliwa. Many years ago, this asteroid might have been a chunk of the Moon, and now it orbits the Sun. The next one is ESCAPADE. Once again, 2 spacecraft, 1 Mars mission. ESCAPADE should be launched somewhere during 2025. It will send 2 small spacecraft to Mars to study how the solar winds influence our red buddy. Many years ago, Mars used to be like early Earth. It had a thick atmosphere and liquid water, but it's now a dry, cold desert. Escapade will help us understand what exactly happened. How and why did Mars lose its atmosphere? 2025 will also be packed with lunar missions. Unfortunately, not all missions are going to be successful. For example, the IM-2 lunar lander reached the Moon's surface on March 6. It was supposed to land near the Moon's south pole to search for water ice. Finding water on the Moon would be incredibly important for our future human missions. If we find a method to turn this water ice into normal water, we'll be able to build entire settlements there. Well, IM-2 was launched on February 27th. It traveled to the Moon successfully and prepared for landing. It made it to the surface, but something went wrong. Communication was lost temporarily, and no one really knew why. When NASA re-established contact, they saw that the lander wasn't in the correct position. One of its 2 radio antennas wasn't working. Turns out it landed sideways, and now solar panels can't generate enough power. And without power, the lander couldn't keep working. By March 7th, the battery was completely drained and the mission was over. But there are more plans. In late 2025, they should launch the Griffin lunar lander. The rover it will bring should explore the Nobile crater, a key target for future moon bases. In somewhere between 2025 and 2026, they want to try the IM-3 lunar mission. It's going to be a 3rd lander with multiple science experiments. Now, what about the planets? NASA's Europa Clipper is currently headed to Jupiter's icy moon Europa. Scientists have suspicions that this place could have water. It might even become a place for future human missions. On March 1st, Europa Clipper flew by Mars and used its gravity to speed up. On August 31st, ESA's JUICE spacecraft, another one that aims at Jupiter's icy moons, will fly by Venus. They might even snap some pretty pictures along the way. Finally, Juno's mission nears its end. Since 2016, NASA's Juno spacecraft has been orbiting Jupiter. It gave us breathtaking images and crucial data. Now, it's running out of time. If all goes as planned, Juno will continue until September before being deliberately crashed into Jupiter to avoid contaminating its moons. All these missions are pushing the boundaries of human knowledge, and we're just getting started.
Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called gravastars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe: dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball, like a bowling ball, onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball, like a marble, across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity. But instead of bed sheets, we're talking about the fabric of space and time itself, or space-time for short. Heavy objects like planets and stars make dents in space-time, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Powell Mazur and Emil Mottola, in 2006. They tried to think, what else besides black holes could happen when a massive star collapses on itself? That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravistar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravistar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravistar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravistar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravistar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in spacetime, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity.
A space mission like this has never been done before. Nearly 20 years in the making. It's so precise that even a millimeter of error could ruin the whole thing. Two satellites are floating hundreds of miles above the Earth with one big goal: to create artificial solar eclipses on demand. This could change how we study the sun forever. But pulling it off is insanely difficult. And let's just say, NASA and the ESA are holding their breath. Proba 3 has successfully launched and already shows promising results. It's made up of two satellites that will fly in perfect formation. Their goal is to block out the sun in space. Well, why do we need that? Because solar eclipses are actually very useful for studying the sun's corona, its glowing outer atmosphere. The sun is obviously super bright, so its corona is only clearly visible during rare fleeting moments when the moon perfectly covers the star during an eclipse. But what if we could recreate that effect anytime? That's Proba 3's main task. One satellite acts as an occulter, a giant sun-blocking disk. It also carries a wide disk about 5 feet wide, which acts like an artificial moon, blocking out the sun's light. The other is a coronagraph. It should capture detailed images of the corona. There's also a third device that should study space weather and how solar storms affect our planet. It's insane how perfectly precise they must be for this to work. They must stay perfectly aligned with their position shifting by no more than a single millimeter, about the thickness of a fingernail, all while they're floating high away from Earth in space with no strings attached. This project was a team effort and a pretty big historical moment. This is the first time that an ESA mission is launched from India since 2001. Proba 3 was built with contributions from 13 European countries, along with Canada. There was a small hiccup before departure, though. The air freight company refused to accept the satellites because their batteries were still inside. The engineers had to remove the batteries and ship them separately. Not ideal, but a small price to pay for getting the mission to the launch pad. The idea first came to mind in 2005 to ESA scientists, and after years of planning, designing, and testing, the mission finally lifted off on December 5, 2024. For the first few weeks after launch, the two satellites stayed connected. Scientists run tests to ensure they were functioning properly. During this time, the coronagraph took its first-ever space image. It captured a beautiful star field in the Ophiuchus constellation. Then, on January 14, 2025, the real mission began. The two spacecraft successfully separated from each other. Over the following weeks, ESA's engineers carefully brought them back together to keep controlled distance. Now that they're in orbit, Proba 3 satellites work in a highly elliptical orbit, swinging between 372 and about 37,000 miles from Earth. This should help ease the Earth's gravitation, meaning the satellites won't need to burn as much fuel to stay perfectly aligned. The spacecraft also communicate with each other using lasers, adjusting their distances in real time. This level of control has never been attempted on this scale before. But the Proba 3 mission isn't only about looking at the Sun. The second satellite, the Occulter, has its own mission. It carries DARA, an instrument that will measure the Sun's total energy output. This is incredibly important for climate studies. Scientists need to know how much solar energy reaches Earth. If Proba 3 succeeds, it'll prove that satellites can fly in space autonomously while staying super precise. This could open the door to entirely new types of space missions. For example, giant telescopes in space, where separate satellites act as one enormous lens. Or more advanced climate monitoring with precision instruments orbiting Earth together. Finally, deep space exploration. Spacecraft could team up to explore planets and moons in ways never seen before. 2025 is going to be full of insane space missions. It's packed with lunar landings, asteroid visits, and planetary flybys. But space is never easy. Missions get delayed, some never launch, and others surprise us. First, IMAP, Interstellar Mapping and Acceleration Probe. This one will launch in September, and it should help us unlock the secrets of interstellar space. It will travel super far away to study the boundary between our solar system and interstellar space. This mission will help us learn more about cosmic rays, solar winds, and what happens when the Sun's influence stops and the actual terrifying space begins. Next, PUNCH and SPHEREX. These two were already launched on March 11, 2025. PUNCH will help predict solar storms before they hit Earth. It will track solar winds from the Sun to Earth and help us understand space weather better. Space weather is important because it can damage satellites and power grids. And SPHEREX will map the entire sky in infrared light, capturing the spectra of millions of galaxies. It could reveal the secrets of how galaxies formed after the Big Bang. Next, we've got TON-2, which should launch sometime in May. It will visit the legendary asteroid Kamao'aliwa. Many years ago, this asteroid might have been a chunk of the Moon, and now it orbits the Sun. The next one is ESCAPADE. Once again, two spacecraft, one Mars mission. ESCAPADE should be launched somewhere during 2025. It will send two small spacecraft to Mars to study how the solar winds influence our red buddy. Many years ago, Mars used to be like early Earth. It had a thick atmosphere and liquid water, but it's now a dry, cold desert. ESCAPADE will help us understand what exactly happened. How and why did Mars lose its atmosphere? 2025 will also be packed with lunar missions. Unfortunately, not all missions are going to be successful. For example, the IM-2 lunar lander reached the Moon's surface on March 6th. It was supposed to land near the Moon's south pole to search for water ice. Finding water on the Moon would be incredibly important for our future human missions. If we find a method to turn this water ice into normal water, we'll be able to build entire settlements there. Well, IM-2 was marched on February 27th. It traveled to the Moon successfully and prepared for landing. It made it to the surface, but something went wrong. Communication was lost temporarily, and no one really knew why. When NASA re-established contact, they saw that the lander wasn't in the correct position. One of its two radio antennas wasn't working. Turns out it landed sideways, and now solar panels can't generate enough power. And without power, the lander couldn't keep working. By March 7th, the battery was completely drained and the mission was over. But there are more plans. In late 2025, they should launch the Griffin lunar lander. The rover it will bring should explore the Nobile crater, a key target for future moon bases. In somewhere between 2025 and 2026, they want to try the IM-3 lunar mission. It's going to be a third lander with multiple science experiments. Now, what about the planets? NASA's Europa Clipper is currently headed to Jupiter's icy moon Europa. Scientists have suspicions that this place could have water. It might even become a place for future human missions. On March 1st, Europa Clipper flew by Mars and used its gravity to speed up. On August 31st, ESA's JUICE spacecraft, another one that aims at Jupiter's icy moons, will fly by Venus. They might even snap some pretty pictures along the way. Finally, Juno's mission nears its end. Since 2016, NASA's Juno spacecraft has been orbiting Jupiter. It gave us breathtaking images and crucial data. Now, it's running out of time. If all goes as planned, Juno will continue until September before being deliberately crashed into Jupiter to avoid contaminating its moons. All these missions are pushing the boundaries of human knowledge, and we're just getting started.
Earth was born dry. It's hard to imagine now, when literally every living thing is made from water. But even though we started as just a scorched, lifeless rock, it turns out water on our planet was literally inevitable. And not just on Earth. Water is inevitable almost everywhere. For decades, scientists believed that it was an accident. Earth's water came from somewhere else. They believed it was accidentally delivered by icy comets and asteroids showering our planet. This theory is a bit weird, because it relies on random cosmic collisions. Somehow, asteroids and comets just happen to hit Earth in the right way at the right time and in the right amounts. But there's no way it could form right here in the solar system. Earth formed way too close to the sun to hold on to any water, right? Nope. Recently, this team of scientists from the Paris Observatory has proposed a new theory. They used data from the ALMA, a super powerful collection of 66 antennas that act like one. And they noticed something strange: a young star called HL Tauri. HL Tauri is essentially a newborn in stellar terms, being less than 100,000 years old. Plus, it's not very distant, situated just about 450 light-years away from us. Astronomically speaking, that's akin to having a neighbor across town. And this star has water surrounding it. It's right inside its protoplanetary disk. The protoplanetary disk is like a giant pancake of gas, dust, and ice that forms around a young star right after it's born. The star is in the center of the system, like the egg yolk, and the protoplanetary disk surrounds it like the egg white. And there it was, tons of water vapor. In fact, ALMA showed at least 3.7 times as much water vapor around this star as in all of Earth's oceans. And this wasn't the only discovery like that. They also studied a young star called V883 Orionis. This one is farther than HL Tauri, about 1,300 light-years away. And there it was too, water vapor swirling in its protoplanetary disk. And then, in another system called PDS 70, makes you wonder just how many star systems with water are out there. And most importantly, how did it get there? Water should be delivered on planets by asteroids, but there were no signs of icy asteroids crashing into the dust, no wild impacts to explain it. It seemed like the water was woven into the disk itself. This discovery changed everything. After deeper study, they finally realized how many planets end up with water on them, including our Earth. So, here's an updated story. Water was here long before Earth existed. In fact, it was here even before the sun was born. It existed in a huge cloud of gas and dust called a molecular cloud. It's like space fog, filled with all kinds of particles. These clouds are nurseries for stars and planets. They're full of stuff that would eventually give birth to our sun. In some super chilly and crowded parts of these molecular clouds, the water existed in the form of teeny tiny ice crystals. These crystals were sticking to random dust particles. Gravity was doing its thing by pulling things to each other. It started sticking dust and rocks together like glue. These rocks already had frosty sprinkles on them. As the region was spinning faster and heating up, it eventually gave birth to our sun. This happened about 4.6 billion years ago, and the sun was surrounded with the protoplanetary disk we mentioned: gas, rock, and some ice that coated all these things. All the stuff that would become the planets. Our Earth started forming there too. It's about 4.5 billion years old, just a little bit younger than the sun. At that time, it was still impossibly hot and dry because it hung out super close to our young star. After about 5 million years, the newborn sun was growing stronger and hotter. The gas and dust began to disperse, and with it, something else happened. The icy rocks in the protoplanetary disk started to heat up. Slowly, their frozen surfaces turned into steam, and now there were billions of these asteroids around the sun, all releasing vapor into space. All that created an enormous, invisible halo of steam stretching across the solar system. The Earth began to move through this mist of water, also drinking it as it went. It soaked up all that vapor like a sponge. It gathered in lowlands, filled up craters, and seeped into the ground. Tiny puddles turned into lakes, and those lakes grew into oceans. From these oceans, life emerged. Now it covers nearly 70% of the planet's surface. So, it wasn't luck at all. Water was written into Earth's story from the very beginning. But the most incredible part is that, of course, this wasn't just an Earth story. If this process happened here, then it could be happening on other planets as well. That means it repeated on Mars, on Venus, and could potentially happen on tons of other planets out there. And this explains so much. Mars used to hold water, perhaps entire oceans, millions of years ago. Venus was a green, Earth-like paradise before the sun pierced through its atmosphere and turned it into a nightmare. And even if water is gone from these places, it still exists on various moons in our solar system, including ours. Well, not really water the way we know it. When Neil Armstrong and his crew landed, there weren't any puddles in sight. That's because on the moon, it's not in liquid form, and not even ice. Instead, it's hidden as individual H2O molecules, scattered everywhere, mixed with dust and rocks. We're actually planning to collect it, not as individual molecules, of course, but by heating it up and turning it into actual drinkable water. And it also showed there might be more water deep underground on the moon, hidden in caves. Some of it is actually lakes, and who knows? Less radiation, more heat, actual water. Maybe we'll even find some microorganisms there one day. All that means we could actually build moon stations in the future. And not just on our moon too. For a long time, Saturn's moon Enceladus was just a bright, icy dot in the night sky for us. We thought of it as a small, frozen world with the surface so reflective it outshone everything else in the solar system. It was beautiful, sure, but no one thought it was particularly special. That is, until Cassini decided to check it out. Instruments on Cassini detected that something was pushing against Saturn's magnetic field near Enceladus. That meant there was gas, maybe even an atmosphere, coming from the moon. When Cassini took a closer look, they were shocked to see that Enceladus was brimming with activity. Cracks near the moon's south pole, later nicknamed tiger stripes, were spewing huge jets of water vapor and ice particles into space. These geysers are like shot material hundreds of miles high. Where in the world was all this water coming from? Turns out, beneath the ice, hidden under a shell of up to 25 miles thick, is a huge ocean, a salty, liquid sea covering the entire moon. We later discovered that there might be a similar underground ocean on Jupiter's moon, Europa. Water is a key ingredient for life as we know it, which is why scientists are always searching for it beyond our planet. Finding water around other stars means those places could potentially support life. Could something be alive down there on these moons? We don't know yet. But one day, a new spacecraft will return and maybe even land on these moons. Whatever it is that we'll find there, it will be a great discovery. Most importantly, these moons could be great for us to build space stations on in the future. So, this discovery doesn't just change our understanding of Earth's past. It opens a door to something much bigger. It means that water could be literally everywhere. Therefore, life can too. We just need to have some patience and find it.
Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale Crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was a 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now, Curiosity stumbled upon something interesting in the Gale Crater, a vast basin on the Martian surface where, billions of years ago, water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate. There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time, show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and is capable of heating Martian rock samples to extreme temperatures. There are two ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced two possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hoped. Well, at least not on the surface. That doesn't mean underground life couldn't exist, though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars. You know, Marsquakes. And it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet. And it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas. And they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. That would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor. And this could help us avoid similar mistakes in the future. Now, scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe or even multiverse. And then this multiverse could be part of a bigger one, and so on, kind of like a stacking doll. Sounds like pure science fiction, but this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know, time, space, matter, breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So, scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star, tens of times bigger than our Sun, this tiny point would have an unbelievable gravity. It's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside a huge black hole inside of another universe? Well, that would be wild. So it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole, like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light years. It would be a cube about 1,000 light years on each side. For comparison, our Milky Way alone is 100,000 light years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wildest part. The resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size or radius of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But the density works the other way around. The black hole gets less dense as it grows. For a size that big of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around, trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while super strong winds try to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. This is the imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon, falling inside, is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. Now, while some scientists think this could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a large multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. Now that would be some weird chain. There's this theory that says that universes could be born inside of black holes, sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there would be a whole new universe forming. So it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. The idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories. So they all remain speculation for now. But at least it's fun to speculate. There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers, a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle, but it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's $1 million questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the Moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. Cosmic allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but Cosmic can detect even the shortest ones that last nanoseconds. Cosmic can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path: a white dwarf star 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we miss the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. Strange explosions in vibrant blue colors are popping up around the universe and keeping astronomers intrigued. This rare and incredibly powerful event has a fancy name: luminous fast blue optical transient. This phenomenon doesn't behave like anything else we know of, and things got even stranger when the most recent one happened in a spot it shouldn't have. To really understand what happened last year, we need to go back a bit. This type of strange explosion was spotted first in June 2018. The blue blast happened about 200 million light-years from Earth and got the nickname the Cow. No, this happening didn't resemble a cow at all, but it did have an unusual format. Back then, this blast was the most asymmetrical explosion ever seen by astronomers. It burst into space in a flattened pancake-like shape, not in a typical sphere as they would expect. This phenomenon was similar to a supernova, which is the most common type of cosmic explosion that happens when a star exhausts its nuclear fuel and collapses under its own gravity. However, scientists also noted three crucial differences. Number one, this phenomenon is more powerful than a typical supernova. When it happens, the blue burst emits more energy than an entire galaxy of hundreds of billions of stars like the Sun. Number two, it's much faster. The explosion reaches its peak brightness and fades away within a matter of days, while a supernova can take weeks or even months to completely dissipate. And the last difference, these blue bursts can also be much brighter. These mysterious objects are considered the brightest known optical phenomenon in the universe. But unlike a regular supernova, it's believed that there are no radioactive elements to power this brightness. So that means the power must come from somewhere else. The question is, from where? This is just one of the mysteries that the scientists are trying to figure out. There have been some heavy investigations since the event was first observed, and 15 telescopes around the world are constantly looking for it. Since 2018, these extreme explosions have been spotted about once a year. So while they're rare, they're not incredibly uncommon. There are several possible explanations for the existence of these fast optical transients. Perhaps the most acceptable one is that it is a stellar corpse. I mean, what is left behind when a star calls it quits. So we're looking at two prime suspects here. They could be a neutron star or a black hole, producing emissions close to the speed of light. The theory goes like this. There is a massive star much larger than those that produce regular supernovas. Then it starts to collapse. Such an event would certainly be expected to leave a black hole behind. Let's say this massive star isn't ready to leave the universe in a quiet way. Instead, it creates a swirling disk around the black hole composed of gas, dust, and other matter, like it matters. This disk, called the accretion disk, can shoot out streams of material at incredibly high speeds, almost like powerful cosmic jets. And that could be exactly what we see as those sudden bursts of light. Again, it's just a theory. What exactly sets off these blasts remains a mystery, and much more observation and analysis are needed. Experts believe that explaining such an oddity is a scientific goldmine. After all, we're talking about a stellar corpse that isn't just sitting there, it's actually quite active. Now, since this event was first spotted, all similar occurrences that our telescopes have captured happened in the same place. I mean, the explosions always occurred in the spiral arms of different galaxies. But last year, things changed. The Hubble Space Telescope left scientists speechless in April 2023 when its images caught this same type of weird explosion happening for the first time in the middle of nowhere. Well, it didn't happen inside a galaxy as it was supposed to. It happened in the space between two of them. More precisely, about 50,000 light-years from a large spiral galaxy and about 15,000 light-years from a small one. This event is known today as the Finch. Oh great, So when we finally get closer to finding some answers, the unusual location of the Finch phenomenon came to mess it up again. So maybe there is another explanation for it. Speculation began soon after the discovery. One idea is that it could have been a collision between two neutron stars traveling far outside their host galaxies. These two could have been spiraling toward each other for billions of years, and when they collided, they produced a flare over 100 times brighter than a normal supernova. For this hypothesis to be correct, one of these neutron stars would have to be highly magnetized, amplifying the explosion. Another possibility is that the explosion was a star being torn apart by a black hole with a mass between 100 and 1,000 times that of the Sun. Although we still have lots of questions, one thing is for sure: the Finch is a luminous, fast black optical transient. Except for the weird location where it happened, it has all the other characteristics to be classified as one. It's super bright, like me, and super fast, and its origin is super hard to explain. Plus, the data from the Gemini South Telescope, the Chandra X-ray Telescope, and the Very Large Array Radio Telescope have confirmed it. Adding this latest information only makes it harder and harder for researchers to finally find some kind of pattern in this whole event. The Finch isn't the only peculiar event in this category. Let's head back to the year before, to 2022. A blue explosion was spotted in September, and it got the nickname of Tasmanian Devil. Just like the previous ones, this blue burst came up and disappeared very quickly. Then, something mysterious happened. Exactly 100 days later, observers who were still tracking the phenomenon got an early Christmas gift. They observed another flare-up, and it was as bright and fascinating as the original one. Wait, so we're talking about two similar and strange explosions that happened at the same spot and close in time? Well, this was a first. Quickly, 13 telescopes around the globe all had eyes turned toward the Tasmanian Devil event, including one equipped with a high-speed camera. Over the course of 120 days, they managed to capture another 14 irregular light pulses. This was certainly amazing because it proved that instead of showing up once and fading away as expected, the Tasmanian Devil continued to explode with supernova-like energies again and again and again. Can you imagine such power? This scenario still intrigues the scientific community because it pushes the limits of physics, not only because such extreme energy production, but also because of the short duration bursts. By the way, its flares last from 10 minutes to about 4 hours. Believe me, on the scale of the universe, that's considered super quick. This was the only time that an extended season of this event was observed. However, after some thought, the scientific community split their opinions about it. On one hand, the Tasmanian Devil could have been an utterly unique and one-of-a-kind event. On the other hand, maybe it was just the first time that our telescopes caught it from a more face-on angle. To further understand what's happening, scientists still need to observe larger samples of the phenomenon. All hopes are in the upcoming Vera C. Rubin Observatory, which is currently being constructed in Chile. It will have a 27.5-foot wide telescope, coupled with the world's largest digital camera ever fabricated for this purpose. According to NASA, this technology might finally give us some answers about these blue explosions. We can expect some exciting times ahead, as this could be the start of a new chapter in our understanding of stellar evolution.
There are probably 36 other civilizations hanging out in the Milky Way, and over 170 billion galaxies, give or take, in the observable universe. Conditions for life are all over space. So, where is everybody? Nuclear physicist Enrico Fermi came up with this exact same question during a lunch break with his colleagues in 1950, leading to one of the most unsettling paradoxes in the universe. Even though there's a huge probability of extraterrestrial civilizations existing, we still haven't found any clear evidence of them. One possible explanation comes from the zoo hypothesis. It suggests that advanced extraterrestrial societies exist and know exactly who we are and where we are, but intentionally choose to stay hidden. They're just observing human quirky behaviors, as if we're in some kind of a cosmic wildlife park. But their intentions could be much darker. If you're a Star Trek fan, you probably remember the main rule for Federation members. Starfleet officers shouldn't contact species that are not advanced to avoid messing with their development, even if it means risking their own lives. Now, even though it's fiction, this rule perfectly captures what the zoo hypothesis is all about. Beings from other corners of the universe see our planet as a cosmic zoo with one-way bars. They can watch us brushing our teeth in the morning or walking our dog, but we can't catch a glimpse of them. In this theory, non-terrestrial life forms deliberately keep their distance from us, sticking to a hands-off policy agreement in the vast cosmic neighborhood. It's like those super smart beings agreed that we needed to have the freedom to shape our own future and destiny, following our own path of development without external contamination. The idea is that these super advanced civilizations could be like, 500 million years ahead of us, which would explain why we haven't seen any signs of them. And maybe it's better this way, as humans could eventually be destroyed or even assimilated by this new cosmic power, Independence Day style. As much as things like going to an art museum might be interesting to us, extraterrestrials probably wouldn't be too thrilled watching us stare at the Mona Lisa painting for hours. Interplanetary cultures might be more into buying tickets to quietly observe how we're developing new technologies, such as ultra-modern satellites. According to the zoo theory, they can't reach out to us until we hit a certain level of development, so improving our technology and wisdom could be the only way to show them that we're mature enough and don't need their spaceship parenting anymore. There are a couple of reasons why it's hard to buy into the zoo hypothesis. Extraterrestrials might not visit or reach out because we're not all that advanced. But it is tough to explain why they keep ignoring all our attempts to communicate. Even if the zookeepers try their best not to interfere with animals' lives and behaviors. I bet they couldn't just ignore a bear speaking in loud and clear English about its desire to communicate. So that's pretty much why humans keep trying and trying to provoke some reaction from inhabitants of other planets using radio signals. In 2017, in a valley 8 miles southeast of the Norwegian city of Tromsø, a radar antenna transmitted some specially composed electronic music to potential intergalactic listeners. The target audience was in GJ273, also known as Lyton Star. It's a runty red dwarf located 12 light-years from our solar system. Since radio waves travel at the speed of light, we'll have to wait more than 2 decades before looking for a reply. But the main problem with radio waves is that we're kind of in the dark about where to look, and civilizations might be as far as 17,000 light-years away. Plus, we don't know which radio frequency extraterrestrials use to chat. Now here on Earth, we use the radio spectrum to send signals into the universe, assuming that what works for us might be a common method for other civilizations. But in fact, it could be considered a somewhat old-school technique for other beings. That's why current projects are now looking for technosignatures, which are signs of technological activity from extraterrestrials, like city lights, solar panels, megastructures, or artificial satellites. Another potential clue is to study the atmospheres of planets orbiting nearby stars, as an advanced civilization might be altering its atmosphere with different gases, making it detectable. Despite decades of observations, there is still no definitive evidence that advanced extraterrestrial civilizations are out there. But that doesn't mean they don't exist. Even by expanding search fields, we're talking about odds much slimmer than hitting the jackpot. with a roughly 1 in 3 billion chance of finding an advanced civilization within a given distance from Earth. Maybe space creatures are responding to our communication attempts, but in a way that we can't understand. The universe has been around for more than 13 billion years, while humans showed up just 200,000 years ago. And this is about 0.01% of the universe's age. It's like we're still learning to talk, while other super smart beings might be sending us messages that are all lost in translation. We keep waiting for a giant UFO to land on Earth and for green ETs with huge eyes to come out of it. But we forget that our intergalactic neighbors could be more interesting in building nanotechnologies to watch over us. They could also be trying to communicate using neutrinos, which are subatomic particles with an extremely small mass that could effortlessly pass through our planet without being detected by our current technological devices. Now, the zoo hypothesis has another issue. It is pretty tough to believe that, with all these civilizations supposedly hanging out in the universe, they would all decide not to reach out to humans. For this to happen, there would have to be a great sense of structure, with a higher intelligence working as the head of the universe, giving them direct orders and clear rules to keep us isolated. But we're talking about billions of possibilities for life, right? More civilizations mean that there are more chances of a violation of this no-contact rule. So, most likely, at least one independent planet would be just as desperate to find life in the universe as we are. Some scientists also believe that if such advanced life had substantially colonized Earth and many other planets, we would know it by now. The zoo hypothesis has two other variations that are even more frightening. In the laboratory hypothesis, nobody contacts us because humankind is actually being subjected to experiments, and Earth is essentially a giant science lab. Otherworldly creatures could be analyzing human responses to various survival challenges, such as tsunamis or massive earthquakes. In this case, the no-contact agreement between all other space groups would make a bit more sense, since it's in the name of scientific research for the greater good, at least for them. The planetarium hypothesis, proposed in 2001, suggests that we are living in an artificial universe, in some kind of virtual reality designed to give us the illusion that the universe is empty when it's not. But no possible generator could test this hypothesis. Besides the zoo, the laboratory, and the planetarium theories, there is another possible answer to the Fermi paradox. Nobody contacts us because humans are completely alone in the universe. This is known as the rare Earth hypothesis, and it emphasizes how Earth occupies an incredibly unique position. No other planet could bring life to the universe that could be more than just bacteria. We may consider ourselves pretty lucky, as even a small change in any of Earth's orbital parameters, like the distance from the Earth to the Sun or the rate of rotation, could make conditions too extreme for people or life in general. But again, it's hard to think that we are alone in this vast universe. So, we're back to the paradox. Where is everybody? Imagine if somewhere, trillions of light years away from our world, there's another version of you watching this very video right now. Not as crazy as it might sound. The multiverse theory is having its time of the day, from Marvel's movies to Spider-Verses to the recent famous hit Everything Everywhere All at Once. But it's not just some wild sci-fi concept. Physicists have been talking about this theory for decades. Let's see what they say. Do parallel worlds exist? If they do, let's hope that this is the reality where you click that subscribe button before diving into the video. Now, everything starts with the Big Bang. Before the Big Bang, the universe, with everything we know, was crammed into an unbelievably tiny, super hot, and mega-dense point. Our universe is about to burst into existence. And then, boom! The most colossal event you can imagine happens. In an instant, this tiny point expands with indescribable speed. It's the beginning of everything: time, space, and all the galaxies that surround us. Then, like an extremely hot balloon,
the universe started stretching out in all directions, which sounds logical, but what's curious is that this inflationary epoch lasted for an incredibly brief time, in less than a blink of an eye. It's like the universe hit the fast-forward button and then everything eventually slowing down over time. After this speedy phase, the universe kept growing, but at a more normal pace. This rapid expansion is called inflationary cosmology. It explains some big mysteries about our world. It tells us why it looks the same in all directions, why the background radiation is evenly spread, why galaxies are where they are, and so on. The details of how this cosmic inflation works are still a bit mysterious, but scientists are on it, and the theory itself is universally accepted. But it wasn't always this way. To scientists, this idea sounded like insane sci-fi at first. However, it explains so many things that the scientists just had no choice but pay attention to it. However, its initial weirdness was just the beginning. Now, according to this theory, inflation might not be a one-time thing. It could be happening repeatedly, maybe even endlessly. Picture the universe as a never-ending cycle, with each burst of inflation creating its own bubble universe. And the most important thing is that these bubble universes might not play by the same rules. Some could be totally weird, where the laws of physics are going crazy in ways we can't even fathom. Which means there might be a whole constellation of bubble universes out there. However, we can't directly see these other bubbles. They exist beyond the edge of our spotlight. That's where the multiverse theory comes into play. People have been chatting about the idea of multiple universes for a long time, like way back in ancient Greece. Now, back in the 1990s, people got really interested in this idea, and this concept started popping up in books and movies. As a result, scientists began talking about it increasingly in scientific discussions and journal articles. And nowadays, many scientists and philosophers are into it. Now, the problem is, there's no solid proof or evidence that these other universes really exist. It's not a proved or confirmed theory. It's not even a theory at all, just a hypothesis, a bunch of interesting thoughts put together. Before we draw any conclusions, we need much more in the way of clues and evidence, and unfortunately, it's hard to find the evidence of parallel worlds when we can't live or look past our own, which is why many scientists believe that it might not be real. But not everybody agrees with that. While critics say that we can't observe the multiverse and therefore can't test it, some physicists suggest a different approach. Instead of trying to find these parallel worlds, we could try to look at ours and its history. Around the 2010s, researchers took a closer look at data from a space gadget called the Wilkinson Microwave Anisotropy Probe. Yes, that's a mouthful. They thought they found signs suggesting that our universe might have bumped into other universes in the past, like sort of a collision. But then scientists used an even fancier satellite, which had 3 times better resolution, looked at the data more thoroughly, and didn't find any strong proof of these universe collisions. Plus, there was no evidence that other universes were tugging on ours with their gravity. However, an interesting discovery happened in 2015. One scientist checked out radiation left over from the Big Bang. He claimed to see something super bright, 4,500 times brighter than expected. Well, at least based on the stuff, like protons and electrons, scientists think existed in the early universe. So he and some others assumed that this might be our first evidence of our universe crashing into others. But let's assume that it does exist. The multiverse wouldn't be about human decisions creating alternate timelines. In quantum mechanics, it's not human decisions that split everything into parallel worlds, but the measurement of subatomic particles. So if we look at this theory scientifically, other worlds would be billions of light years away, and what's happening to them wouldn't have anything to do with our daily choices. So what would it look like? Well, Max Tegmark, for example, talks about 4 levels of universes and multiverses. Level 1 is the extension of our world. Our universe is a big place, and in an infinite universe, there would be infinite chunks like ours, each with its own story. Most of these chunks might look different from ours, but because there are so many, some might look just like ours.
but they'd be really, really far away. Level 2 is a universe with different physical constants. This idea says that our universe is part of a much bigger space where bubbles form. Each bubble might have its own set of rules, like different laws of physics. Level 3 is the many worlds interpretation of quantum mechanics. This one's a bit tricky. In the quantum world, things can be weird. Imagine rolling a dice. Each number that comes up might create a separate universe. So if you rolled a dice and got a 3, in another universe, it would be a 6, and so on. Yeah, my head's spinning. This idea suggests that every possible outcome in quantum events creates a whole new universe. And level 4 is the ultimate ensemble. This level gets super abstract. It says that everything, every possible universe or reality, can be described using math. I wish now I hadn't fallen asleep in algebra. Imagine all the different math equations describing every conceivable way the universe could be. This level says that every math equation that can describe a universe actually exists, and they're all real in their own way. Stephen Hawking was a proponent of the Level 3 many worlds interpretation. It was one of his last theories before he passed away. He predicted that the universe is finite and far simpler than many current theories about the Big Bang say. According to Hawking, the universe is like a giant quantum system, a sea of possibilities and probabilities. In this view, every outcome of the universe's history plays out in parallel existences, and we, as observers, play a crucial role. Our existence and what we observe, according to Hawking, actively shapes the universe we see. In simple words, the universe is a canvas and we're all painters. Sounds very cool and insane, but hey, many things in science were considered crazy before they turned out to be true. So, is there another copy of you somewhere watching this video and who just pressed the like button? Who knows? If there are infinite copies of us, scientists assume that we might be like identical twins, sharing the same origins and starting from one thing, but then developing into separate different people. And if these worlds exist, perhaps we can even visit them one day. There could be some connections between us, something that could allow for interdimensional travel. For example, wormholes. Well, whatever the truth may be, let's hope that one day we'll discover it. Until then, stay curious.
The universe is a big, mysterious, and ever-changing place. But just like we have baby photos that show how we looked when we were little, scientists also have a baby picture of the universe. Only they were able to look 14 billion years into the past. How is it possible? Well, let's figure it out. Imagine winning the Oscars of science for a picture that shows the entire universe when it was just a baby. Scientists achieved this fantastic feat using NASA's Wilkinson Microwave Anisotropy Probe. To take this picture, they built a super cool satellite, launched it into space, and collected massive amounts of data about the universe. This image turned out to be a cosmic treasure trove. It helped answer some of the universe's biggest questions, but also revealed a few new mysteries. This groundbreaking data confirmed the standard model of cosmology and told us that our universe is around 13.7 billion years old. Plus, it showed us that the elements in our regular periodic table make up only a tiny fraction of the universe's recipe. To be honest, this is not quite a photo in the usual sense. Of course, we cannot actually photograph what happened so long ago. The picture we're talking about is called the Cosmic Microwave Background, or CMB for short. Now, the CMB is like a faint glowing light that fills up the entire universe in every direction. These clues that can help us understand how the universe evolved into what it is today. CMB is a super cool glow that fills up the entire universe. You see, when you look through a regular telescope, the space between stars and galaxies seems pretty dark. But with an amazing radio telescope, we can actually detect that this empty, dark space is filled with a super faint and even glow. This glow is all around us, and it's not coming from any star or galaxy. This is the cosmic microwave background, and it's strongest in the microwave part of the radio spectrum. The CMB is a frozen treasure, super chilly at around -455 degrees Fahrenheit. Bruh, that's colder than any winter you've experienced. This ancient light formed about 380,000 years after the Big Bang, which happened around 14 billion years ago. So we're looking way back in time. In the beginning, the universe was like a thick fog of incredibly hot plasma. It was almost 500 million degrees Fahrenheit. It was so hot that atoms couldn't even exist yet, only wild electrons and protons bouncing around like crazy. Because of this super hot fog, any light that tried to travel got scattered by those mischievous electrons. It was basically like trying to see through a foggy car windshield. But then, the universe started expanding in all directions, just like a cosmic balloon getting bigger and bigger. And it's still expanding today. As the universe did that, it began to cool down. When it turned 380,000 years old, it finally cooled enough for electrons and protons to come together. These tiny particles started to combine, forming mostly hydrogen atoms. When that happened, the universe finally became transparent, like a clear window. The moment of this magical transition is called the recombination epoch. Once the foggy era ended, the light could travel freely. The universe became like a vast playground for light to bounce around and explore. And, as you know, light has a certain speed, 186,000 miles per second to be specific. And it takes some time for light from distant places to reach us. So, in other words, the CMB is the oldest light in the universe. It's like a capture from a moment when the universe just started to become clear and transparent. As this light traveled through space, it went through all sorts of adventures, like the formation of stars and galaxies. Along the way, it lost some energy and transformed into microwaves, which our eyes can't see, and that can be detected only with special tools. Also, there are some tricky things that can mess with the data. For example, galaxy clusters. These are big groups of galaxies hanging out together in space. When the ancient light from the CMB travels across the universe, it encounters these groups, and these sneaky clusters try to leave their marks on the CMB. They distort the patterns in the ancient glow, like smudging the ink in the important ancient book. That's why scientists have to invent techniques and supercomputers to help clean up this mess and decode everything properly. Due to all this, the CMB isn't perfectly smooth. It has a few little bumps and patterns. These weird patterns make it unique, kind of like the universe's fingerprint. Scientists have been using amazing tools like the Cosmic Background Explorer and Wilkinson Microwave Anisotropy Probe to study these patterns. The COBE, our cosmic camera, took the first ever map of the sky in microwaves from 1989 to 1993. Why do we study it? Well, because the CMB can help us learn so much about the early universe. Stuff like how it expanded, how much normal matter and mysterious dark matter it had, and even the overall shape of the universe, and much more. We're basically playing detective with the cosmos, trying to decode the mysteries of our world by little clues and prints. What are the results? Well, awesome tools like the Wilkinson Microwave Anisotropy Probe helped us to learn more incredible facts. For example, we found out that we can actually only see 5% of the universe. Imagine the universe as a cosmic pie. Scientists learned that 68% of it is made up of something called dark energy, and 27% is dark matter. Only a tiny 5% is made of normal matter, the one that we, humans, can see. So, most of the universe is like this hidden realm we can't even imagine. We also found out what happened in the beginning of times. Picture the universe right after the Big Bang. It was so tiny, way smaller than a proton. Everything we see today was crammed into this itsy-bitsy space. The rules of quantum mechanics, which let weird and wild things happen, were in full swing back then. Matter and energy were like playful adventurers, borrowing from the future and disappearing into nothingness. Then, cosmic inflation happened, and the universe suddenly expanded like popcorn on a cosmic scale. It became a trillion times bigger than it was, creating waves of gravitational chaos everywhere. Some gravitational waves filled the baby universe like a sea, and their patterns left unique fingerprints on the CMB light. And all that learned thanks to the pictures of the CMB. Anyway, NASA has this awesome plan to study the universe's baby picture. They're going to use a really cool observatory called PIPER, which stands for Primordial Inflation Polarization Explorer. Imagine PIPER as a special space balloon that's going to fly up high in the sky from a place called Fort Sumner in New Mexico. It has two powerful telescopes that sit in a hot tub-sized container filled with liquid helium. This liquid helium is super cold at around minus 452 degrees Fahrenheit. But PIPER loves the chill because it's extremely sensitive. What is its mission? To learn all about the early days of the universe, right from its first baby picture. When PIPER is up there, it's going to look very carefully at the CMB, trying to find some hidden patterns that hold the secrets of how the universe grew and changed over time. This spy with a magnifying glass will be examining 85% of the sky. PIPER's launch is scheduled for late September. You can even watch the exciting balloon-filling action live on the Columbia Scientific Balloon Facility website. It's going to be out-of-this-world fun. So, the cosmic microwave background is like a time-traveling storyteller, giving us valuable clues about the universe's incredible past. Isn't that awesome? Space is full of surprises, and there's so much more to discover. Keep your eyes on the stars, and who knows what else we'll find out there.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.